In the next operation, we have to create a 2D high-speed dynamic mill. A 2D high-speed dynamic mill utilizes the entire flute length of their cutting tools to produce the smoothest, most efficient tool motion for high-speed pocketing. The toolpath supports a custom entry method and many others. Microlifts further refine the dynamic milling motion and avoid excessive heat buildup. The custom feeds and speeds optimize and generate safe tool motion. Dynamic mill machines pockets material that other toolpaths left behind and standing bosses or cores. The toolpath depends on the machining strategy that you choose in the chain options. The outside chain contains the toolpath. All inside chains are considered islands. With that being said, we will create the toolpath. Go up to the top and select Toolpaths. Select 2D High Speed and go to Dynamic Mill. From here, Mastercam will ask you to enter a new NC name. I'm going to leave the default one that was brought up for me, tutorial number 7, and select OK. From here, go to the chaining options and select this button right here, select machining chains. From here, select solids as opposed to wireframe. Under the solids command, ensure that this face is the only one selected and deactivate loop if it defaulted to being turned on. From here, we will go to the top view in our WCS in the top ribbon bar. Select this face here, and this face here. Once this is done, select OK. And select OK on the Chaining Options dialog box. Ensure that Dynamic Mill is selected and that your chain geometry is selected to 1. When this is done, scroll over to the left-hand side and select Tool. Select Library Tool, go to Filter, and select None. From here, under the Toolpaths types, select Flat End Mill and make it equal to a tool diameter of 532 and hit Enter on your keyboard. Select OK when finished and grab tool number 283 and select OK. From here, we will insert the comment, machine the 3 pockets. Once this is done, you can change your feed rate, plunge rate, and spindle speed. I'm going to do so. I'm going to change my feed rate to 154, my plunge rate to 30, and my spindle speed to 9,000, and hit Enter on my keyboard once those values are inserted. I will then go on the left hand side to cut parameters. I will change the step over from 25 to 15% and hit Enter on my keyboard, followed by the min toolpath radius to 5. From here, I will also take stock to leave on floors and walls and make it 0. Next, I will go to entry motion. Under the entry method, ensure that you change helix only to profile. This will shade out helix radius. From here, make sure that the Z clearance is 0.125 and that your plunge angle is 2. The plunge angle sets the angle of descent for the entry motion and describes the pitch. Along the left-hand side, select linking parameters. Select clearance and give it a value of 1 and ensure that it is absolute. On the retract, make sure it is absolute 0.25, the feed plane is incremental 0.1, top of stock is absolute 0, and the depth is incremental 0. Once this is done, select OK. Your toolpath should be generated. Select the isometric view and run your backplot and verify. Select the play button. Your toolpath should look as shown, and your part should also look as shown. Select Exit when finished. And toggle your display off.